Good morning, all of you. In previous class, already we done the electric field intensity due to axial and equatorial position. Axial in one method, whereas in equatorial method, equatorial position, two methods are done. Now, in this class, we read underline torque on a dipole. Torque on a dipole in a uniform electric field. In a uniform electric field. Torque on a dipole. Dipole means electric dipole. Torque on a dipole means torque on a electric dipole. Torque on a dipole in a uniform electric field. In place of uniform electric field, what is torque acting on due to dipole? Uniform electric field means if electric field lines are parallel to each other. Uniform electric field means electric field lines are parallel to each other. That means field lines are parallel with each other. Field strength, otherwise field strength is same, uniform. Field strength, electric field strength is same at any point. Uniform electric field. Now, torque on a dipole, taking 3 mark question, taking 3 mark. Important also for exam point of view. Derive an expression for torque on a dipole in a uniform electric field. Derive an expression for torque on a dipole in a uniform electric field. Statements. Let us consider an electric dipole. Let us consider an electric dipole plus Q and minus Q. Let us consider an electric dipole plus Q and minus Q and having a small distance of separation, to A which is placed in a uniform electric field, making an angle theta, with electric field. This is the statement. Now diagram or figure. Let us consider an electric dipole plus Q and minus Q and having a small distance of separation to A which is placed in a uniform electric field, making an angle theta with electric field. Now diagram. Suppose this is uniform electric field. Suppose this is uniform electric field. Uniform electric field. Electric field lines are parallel to each other. And this is the dipole, electric dipole. Suppose this is electric dipole. This is a uniform electric field. This is a uniform electric field, parallel, not anti-parallel. And this is dipole, minus Q plus Q. This is a dipole which is placed in a uniform electric field. This is a dipole which is placed in a uniform electric field. And distance of separation is, we are assuming already in this statement, 2a. Distance of separation is 2a, plus Q and minus Q is charge, and this dipole making an angle theta. This dipole making an angle theta with respect to E. This dipole makes an angle theta. This dipole makes an angle theta with respect to E. That means, suppose this angle is theta. Now, from this figure, from this figure, force exerted on plus Q charge B, force exerted on plus Q charge B, that is F equals to, we know E equals to F by Q. Therefore, F equals to Q into E. Understand? Similarly, in this case, F equals to Q. Charge is Q into E along direction of E. F equals to Q into E along direction of E. That is, in this case, force exerted on plus Q charge, force is F equals to Q into E in this direction. But whereas in this case, similarly, force exerted on minus Q B, F equals to minus Q into E. F equals to, charge is minus Q, electric field is E. That is, F equals to Q into E, opposite to the direction of E. That is, in this case, here also force is exerted, which direction is F equals to Q into E, and the direction is towards this. This is along the direction of electric field. This is opposite to the direction of electric field. Why and how? In electric field lines, we already told it. In ahead, in electric field lines, already I told you about how you localize, how you find the direction of force. Here, force exerted on positive charge B, F equals to Q into E along direction of E, whereas or similarly, force exerted on minus QB, F equals to minus Q into E, direction is opposite to the direction of E. As a result, net force will be F equals to, suppose this is F1, suppose this is F2. The net force F equals to F1 plus F2, that is QE minus QE equals to 0. As a result, net force will be F equals to F1 plus F2, value of F1 equals to Q into E, whereas value of F2 equals to minus Q into E. Therefore, net force will be F equals to F1 plus F2, F1 equals to Q into E, F2 equals to minus Q into E, and the result is 0. Sum is 0. Hence, write down, hence, net translating force, hence, net translating force on a dipole is 0. Hence, net translating force on a dipole is 0, but to equal and opposite forces, but two equal and opposite forces are at different points. How? In this point, F equals to Q into E, whereas in this case, F equals to minus Q into E. If magnitude taken, only magnitude, then F equals to Q into E. Here also Q into E. Therefore, we can write, but two equal and opposite forces. Direction of force is here towards right. In this case, direction of force is towards left. That is, indirectly we can say that direction of force is along the direction of electric field, whereas in this case, direction of force will be opposite to the direction of electric field. Therefore, but two equal and opposite forces are at different points. This point, force, magnitude of force, this point, magnitude of force are equal. Whereas at this point, direction of force is towards right, whereas in this point, direction of force is towards left. Hence, they form a couple. Hence, they form a couple which exerts torque. Hence, they means these two contacts. Hence, they form a couple which exerts. That means here this is uniform electric field. This is the dipole. If this is in this is a point plus Q and this is a point suppose minus Q. Suppose these are electric field lines. Uniform electric field lines are parallel. Electric field lines are parallel. If we place a dipole in this manner, making an angle theta with respect to uniform electric field, then at this point plus Q, direction of force is towards right. At this point, direction of force is towards left. Then this direction right, this direction towards left. That means it form a couple which exerts torque. That's why torque equals to, therefore torque equals to either force into perpendicular distance, Here perpendicular distance, how can you draw? From this, draw a perpendicular, either force into perpendicular distance. Here, this is the perpendicular distance, particularly this is the perpendicular distance. How can we calculate? Suppose this angle is theta and this is 2a. We know sin theta, only relation sin theta, not cos, tan, cot, only sin. Sin theta equals to, formula is sin theta equals to, this is the right angle triangle, this angle is theta, therefore sin theta equals to P by S. Suppose this point is A, this point is suppose B, this point suppose C. Then sin theta equals to, from this figure we can write P, that is a C, by S, that is a B. That means sin theta equals to perpendicular by hypotenuse, that is AC by a B. That implies sin theta equals to AC remaining same. This is perpendicular distance, whereas AB equals to 2A. AB equals to 2A. Therefore, AC equals to 2A sin theta. 2A sin theta. AC equals to 2A sin theta. Therefore, above expression becomes we can write torque equals to, above expression becomes, that is torque equals to torque whose symbol is tau. Torque whose symbol is tau. that is tau. Symbol is tau. In some teacher pronounce tau, not a tau, that is tau. Tau equals to either force, that is Q into E, either force into perpendicular distance. Perpendicular distance we get already 2a sin theta. 2a sin theta. Now solve. That implies tau equals to Q into 2a into E sin theta. Q into 2a into E into sin theta. That implies tau equals to Q into 2a electric dipole moment. Q into 2a electric dipole moment. P E sin theta. Since mention the origin in the right side, since P equals to Q into 2a. That implies in class 11th, tau equals to, in vector form, we know in class 11, if AB sin theta, then we can write A vector cross B vector. In similar manner, we can write tau equals to P vector cross E vector. This is also expression, required expression. This is also another expression. This is in vector form. This is in general form. Lastly, this is the required expression for. This is the required expression for torque on a dipole. This is the required expression for torque on a dipole in a uniform electric field. Different cases. Different cases. First case number 1. First case, if theta equals to 0 degree. If theta equals to 0 degree, that means if this dipole is along the direction of electric field. If the dipole is along the direction of electric field. If theta equals to 0 degree, that is also we can say it is just parallel to electric field. This dipole is parallel to electric field. That's why angle should be 0 degree, theta equals to 0 degree. If it is anti-parallel, then angle should be 180 degree. But first case, if theta equals to 0 degree, then tau equals to, formula is P sin theta. That implies tau equals to PE sin 0 degree. In place of theta, you put 0 degree and sin 0, 0. That's why torque equals to 0. Since sin 0 equals to 0 degree equals to 0. No torque exerted. Result, no torque exerted. Second case, if theta equals to, second case, if theta equals to 90 degree, second case, if theta equals to 90 degree, if this dipole is placed perpendicular, if this electric dipole is placed in the uniform electric field perpendicular, if theta equals to 90 degree, then if theta equals to 90 degree, then tau equals to P sin theta. That implies tau equals to P sin 90 degree. That implies tau equals to PE, since sin 90 equals to 1. result torque is maximum. Torque is maximum. Star mark, note below. Very important parts. Star mark, note below. The direction of torque will find will be found by applying right hand screw rule. By applying right hand screw rule. Right hand screw rule. Right hand, underline it. Right hand screw rule. How? Suppose this is direction of E. Suppose this is direction of E, electric field, and this is the direction of P, electric dipole. Suppose this angle is theta. As a result, direction of torque is this direction. Suppose this is a plane. Again, suppose this is a plane. This is a plane containing direction of E and the direction of P, taking an angle theta with each other. Then this is the direction of torque. This is the direction of torque, which is perpendicular into the plane of the curve, into the plane. In the right hand, suppose the direction of this is the direction of E. Suppose the direction of E, and suppose the direction of electric dipole, and this angle is theta in between E and P. Then this is the direction of torque. Suppose this is the direction of E, and this is the direction of P, electric field direction, electric dipole direction. This is the angle in between electric field and electric dipole. As a result, this is the direction of torque. In this figure, exactly this is the direction of electric field, this is the direction of electric dipole, and theta is the angle in between electric field and electric dipole. As a result, direction of torque is like this. That is, which is always perpendicular into the plane. Understand? Draw the diagram.